We'll continue with this packet now. We'll finish on Monday. There's one extra little page I'm going to add on Monday. I was just saving it to Monday because if I don't, you'll forget it over the weekend. It just pertains to one specific problem you're going to get, and I'll just pass that out on Monday. But everything else will go from here. What do we call what you're looking at right now? What is that called? Well, sigma is the symbol. Summation notation. Yeah, this is summation notation. It's just telling you that we need to add. In order to find the sum, what do we need? What do we need in order to find the sum? The common ratio. Do we have that? Yes, we do. What is it? It's the base. In summation notation, the common ratio is the base. It's -2. What else do we need? We need a sub 1, which is the first amount. Do we have that? No, we do not, but how can we find it? When you're in summation notation, plug in the lower limit into the variable. The lower limit is 1. What's 1 minus 1? And what's -2 to the 0? What's anything to the 0? What else do we need? We need one more amount. N, yeah. And how do we find N in summation notation? Upper minus lower plus 1. 9 minus 1 plus 1 is 9. In order to find the number of terms, it's the upper limit minus the lower limit plus 1. So put in always plus 1 at the end. So what ends up happening, because I've done this more than once, is, hey, well, he got 9, this says 9, so that must always be N. Which, of course, then we're going to throw a curveball at you, and we're going to change where to start. Like, hey, we want you to start up at the third number. Well, now guess what? That's not going to be N anymore. So just to be safe, don't say I didn't tell you. Upper minus lower plus 1. And now we can find the sum. The sum of these 9 terms is equal to, what's the first amount? 1. I'll go ahead and do it on this one just because we're here and we're still kind of waking up. So I'll go ahead and write the 1. But think about it. There's a parentheses coming next. Like, you don't need a 1 outside of a parentheses. But I'll just do it for this one. Because if not, you're going to be like, oh, where did that 1 go? 1 minus common ratio, which is 9. No, sorry. Which is -2 to the 9th over 1 minus -2. And let me make sure that 9's inside, because I don't want you to get confused. There you go. Any thoughts? What do you want to do? What you want to do, man? Yeah. What? Okay. Yash? Yeah. This one that is outside comes from here. And I showed you the same formula but written 2 different ways. You can either write it outside, which is the way I'm going to do it because that's the way it's going to show up on your test. So I'll just, they give you the formula. I'm just going to do it that way. Where's the other place I told you that it could go if you wanted to? In the numerator, yeah. In the numerator, you could do it there too. Anywho, so you don't need the 1, so I'm not going to write the 1 anymore. And I asked you a question. What should we do next? Good. Okay, you guys said exponent, that's good. Now, what? See, the thing is, we get captivated by these double negatives because we've been trained since we started algebra, hey, double negative, turn it to a positive. What operation are you doing when you turn a double negative into a positive? You're actually doing an operation. You're multiplying. Even though you can't see it, like this one here that's about to become invisible, well, this also has an invisible one there. So this is asking you to multiply -1 times -2, but in order of operation, what comes first, multiplication or exponent? Yeah, so you got to do the exponent first. So I'm going to stay with this 1 minus. Nothing happens there. -2 to the ninth, I believe, is -512. Correct me if I'm wrong. And then 1 minus -2. This one I could do if I want. That gives me 3. Now I can do my double negative. So sum of these 9 numbers is equal to 513, because this double negative became a positive, over 3. Sum of these 9 numbers is 1 plus 512 is 513. What'd you get? 171. To my calculator people out there, okay, just also for full transparency, here's what you're going to be assessed on, because there's a lot of gray areas here. There's some problems where I would encourage you to do what I did, which is to go one step at a time. There's some problems where just because usually when there's decimals involved, where I would just tell you know what, just put it in the calculator. So you're not going to really be assessed on that middle area. When it comes to the tests and quizzes, what we're looking at to see is, did you substitute correctly? Like literally, you would be getting, hey, did you put a first amount where it goes? That's a point. Did you put common ratio where it goes? That's a point. Did you put, number of terms where it goes? That's a point. So we're looking at the substitution step, and then we're looking at really the evaluation step. So if you're a calculator aficionado, and you know how to put that whole thing in the calculator, whatever, fine. But it has to show up on the paper, like showing where you substituted. If this is all you have, we're going to have a problem. Make sense? What do you think, Miles? Miles agrees. Perfect example. You get something. Now, we have taken measures on the quiz and the test to try to avoid what I'm about to show you, to people taking advantage, but especially when it comes to multiple choice, there's not so much that we're willing to do, but find the sum of this series. Oh, geez, yes, thank you very much. -2 plus -12 plus -72 plus negative, well, that defeats the purpose. So the way we eliminate this is not by giving you 5 numbers to add, we'll give you 35 numbers to add, and then knock yourself out. Yeah, that's fine, okay. Good luck finishing the test on time. So let's do what we were intended to do, which is use the formula. What do we need in order to find sum? What do we need in order to find sum? We need the initial amount. Are we given that? What is it? Fantastic. What else do we need? Number of terms, which they don't explicitly tell us, but we know how to count. How many numbers are there? There's 5. And we need the common ratio, which again they don't explicitly tell us, but you can either tell me by looking at it, or if you're ever not sure, go to the number in front and divide the number behind it. It should always give you the same thing. What are we multiplying by there? Very good. We are multiplying by 6. All right. So the sum of these 5 numbers is equal to the first amount, which is -2, times 1 minus the common ratio, which is 6 to the 5th power over 1 minus 6. That formula will show up on the quiz and on the test. Sum of these 5 numbers is equal to -2. Look, if you want to put that entire thing in the calculator and just spit something out, that's fine. I just got to see that where you substituted. But I'll do the whole thing. What's 6 to the 5th power? 7776 over -5. Which gives me -7775 over -5. Somebody calculate that for me, por favor. Just digits. Gracias. And then that would be what, 3? That sounds about right. Negative, thank you. Where were you there, Thomas? What did you shoot yesterday, Thomas? You didn't take a scorecard? How do you leave in the middle of a round, man? Oh, okay. Then in that case, that's fine. That's a DQ though. Any questions? Ooh. I'm not a huge fan of the wording and the way this was arranged. I prefer if they were to use the word finite, first of all, because that symbol there denotes that it's going on forever. And I realize that here they do tell you n is 7, but that doesn't tell you where to start. Just because n is 7 doesn't mean that, hey, we're going to start adding on the 3rd number. Like you don't know where you're going to start. But so we are going to have to make some assumptions here. Let's assume we already know the number of terms is going to be 7. Let's assume that the first number they want us to start adding at is this first one here, which is 1. So then what's the only thing we're missing? Yeah, that one. What's the common ratio there? How do you know it's -5? How do you know it's negative? That's the key thing. The signs alternate. Okay, anytime you see the signs alternating, now of course where you're going to get confused, and now they're going to give you one that has all negatives. We're going to do one like that later. And you're going to see all negatives, and you're going to be, oh, it's negative. No. If the signs stay the same, the common ratio is positive. Because anytime you multiply by a positive, your signs stay the same. If you have a negative and you keep on multiplying by positives, it's just going to stay negative. But when the signs are alternating, my common ratio is negative, and in this case, it's going up by a magnitude of 5. So common ratio is -5. Julian, makes sense? No YouTube? Makes sense here? Good. So the sum of these 7 numbers is equal to, now here, this case I'm not going to do it anymore. That's it. I've given up. When the a sub 1 is 1, we don't need it outside. Anything times 1 is itself. So I'm going to just jump to the inside of the parentheses and write 1 minus the common ratio, which is -5 to the power of 7 over 1 minus -5. What happens when you take a negative base to an odd power? It does stay negative. So somebody with a calculator, please help me out. What'd you get? -78125. Hannah, do you agree with him? Why not? So assuming Alexi is correct, now I can do that plus and 78126 divided by 6. Jenny's gonna be my go-to. Hey, what happened? Why did they get erased? One 3021. Everybody get that? Is that what you got, Landon? Good. How we doing today, Caleb? Good. Ooh, how's this one different? You don't have an N. What's different? What are they asking you for? Yeah, so that's what I wanted to hear. Here they're not asking you for a sum; they're asking you for a number of terms. Well, that's kind of interesting, right? Because for specifically when we're looking for n, I gave you a little bit more flexibility because I gave you a couple of extra formulas. Now, there's one that only works with summation notation that we just used today, that upper minus lower plus 1. That's only going to work in summation notation. But remember, I gave you the one with log, so keep that in mind. Now, which formula I use depends on what I'm being given. And in this case, since I'm being given the sum, I'm just going to use the sum formula. Okay? But instead of putting sum in, I'm going to actually write the number in. Negative 4095 is equal to, what's the first amount? In order to be able to find number of terms, they have to give you the other three. And they do. Negative 3 is the first amount. Then 1 minus common ratio to this power of n that I'm looking for over 1 minus common ratio. Now, unlike the last one, see, because we're looking for n, the variable that I'm looking for is not isolated. So whereas I told you, hey, on these that we're looking for sum, as long as you substitute and then evaluate, we'll be fine. Well, yeah, because the variable is isolated, there's no need to solve. If you're just giving me that and an answer, on these we're going to have a problem. These have to be solved. There have to be steps here. Now, there's a little bit of wiggle room as to how many steps. So sometimes there's more than one way to get there, but definitely there's going to have to be steps. Julian, what would you do first? We're looking for n. You don't say. That's what I just said. So how are we going to do that, Julian? Yes. Okay, and somebody last period said the same thing. I do not have a problem with that. You can absolutely divide by this negative 3, but just to show you how maybe I can do things a little bit differently. I don't like to do things to both sides until each side is simplified. And I see that, and not because you have to. Your divide by negative 3 is fine, but my attention goes to that 1 minus 4, and then I get rewarded for that because I get lucky. That 1 minus 4 is negative 3. And that ends up just canceling. And if you think you're out of the woods, though, you'd be incorrect because I'm not trying to be mean here. I would venture to guess that more than half of you, even if I were to give you this, would not be able to solve it because of the steps involved. I only have 3 steps. The second one is going to be the one that I think that would get most of you, but I'm not even sure about the first one. What would be the next step? There's 3 steps left. So, okay, fair enough. So see, some of you, good. We do have to get rid of this one by subtracting. If you get confused by one of these, let me know. Here's the one that I think most of you would not get. Yeah. Ah. Yeah, and last period somebody told me to take a square root, which is I think at least I don't mind you saying take a log because that's what you should be saying if you're gonna that's the mistake people would fall into. See, but the reason why you don't take a log, that negative 4 is not what's being taken to the power. Okay, the base here is not negative 4. That base is just 4. If the base were to have been negative 4, that would have had to have been in a parentheses. And that creates a whole other issue that we'll get to in a second because it's negative. So this is like saying a negative 1 here times 4 to the n. So how would I get rid of that negative 1 in front? You could divide. That would work. We also learned the multiplication property of negative 1, which is I can just multiply both sides by negative 1. So be honest. How many of you knew to do that before I said to? Before I said to do that, how many of you knew to do that? Huh? To get rid of the negative before you do a log. Yeah. Now we could do the log. What base would the log be? Yeah, so log base 4. I'm guessing you're going to use change of base on your calculator. And what is that? What's log 4096 divided by log 4? 6. So 6 is equal to n. Oh, Yash, we covered that. We spent an entire unit learning change of base, man. Log 4096 divided. Like you've come to my lab and I've shown you. We've typed that in. Do you have a calculator on you? Log 4096 divided by log 4, change of base. Log 4096, close the parentheses, divided by log 4. Like I remember working with you specifically on this. All right. Same thing here, determine n. I was going to let you do this one together, but I decided against it because of the ratio. I'll let you do I think there's one down here where we can do. Yeah. Let's do this one together. Okay. Again, in all of these, we're looking for n. So they have to give us the sum, which they do is 370 is equal to the first amount, which is -2. 1 minus, here the common ratio is -6. So that goes into the parentheses to the power of n that I'm looking for, 1 minus -6. Any thoughts? Yeah, I like that. That's what I tend to do. Is I look here, 1 minus -6. I can't do it on top though. The top, even though that looks ugly with a double negative, you can't do anything there because of the exponent. So I would get 1 minus -6 to the n over 7. So now to really confuse you, since that's what I do best, I'm gonna do the next 2 steps in 1 step. But if you what would you do next? Okay, and if you were to get rid of the 7, how would you do it? By multiplying. But then after you get rid of that 7, what would you do next? Get rid of -2. How would you do that? By divide. Guess what? I can do it in 1 step. If I just multiply by the reciprocal. So if I just multiply by -7 over 2, that's going to knock out the 2. That's going to knock out the negative. It's going to knock out the 7. But you don't have to. You can do it in 2 steps. I don't have a problem. Just like to challenge you. What's negative times positive? Negative. What's 3 times 370 and then divided by 2? No, wait. I'm sorry. I said 3. What is 7 times 370 and then divided by 2? Oh, you did it already for me up here. Cool. 1295. And then yeah, just like the last one, the same way we had to get rid of that 1 before by subtracting, we do it again, -1, -1. So negative 1296 is equal to -6. So now that negative that I told you caused us problems, at least now it's a little bit easier to see. How did I get rid of that negative in front the last time? Multiply by -1, so just do that again. And that gets rid of this negative and that negative. So I get 1296 is equal to -6 to the n. Here's why we did this one together. And I'm not going to go too much in depth into this because it's going to take a lot of time and it really isn't worth it. So this is going to be kind of one of those take my word for it type of things. What should we do next? Take the log, right? But it's a negative base. You can't take a log with a negative base. Well, do you remember that formula I gave you yesterday that involved logs? Yeah, remember how I had absolute values? So like, and remember also how that formula was used to find n? It was a formula that was specifically used to find n. So when you're looking for number of terms, You can basically just ignore the negative. Just do a regular log basic, because if you put a negative, it's going to give you an error. So what is log base 6 of 1296? Yes, I'll let you do it since now you know how to do it on the calculator. Yeah, you will have to find number of terms. I would like you to know how to find number of terms regardless of what the common ratio is. But yes, it's a safe assumption that you are more likely to get, on those types of problems, you are more likely to get a positive common ratio. So we don't have to deal with the people saying that they were confused. Right, Landon? All right, that one you should be able to do. I'll give you like a minute of a head start. See if you can beat Sophie. Sophie's gonna beat all of you. Find the same thing, number of terms. How many terms do you have to add in order to get that sum? Go, Sophie, go. Go, Sophie, go. SOPIHE. Sophie, Sophie. Yay, Sophie. ALY. ALY. What does it spell? Ali. Give me an A. A. Give me an L. L. Give me a Y. Y. Because we want her to work on the problem. You get it? You see what I did there? It was like the letter Y, but I changed it into WHY. If you're going to mess this up, it's because you messed up the common ratio. So before you get too far, just make sure you put the common ratio as a positive 3. Even though all the terms you see are negative, because the signs aren't changing, the common ratio is positive. I'll do this without a calculator, just to show off. Where's your phone, Caroline? Where is it supposed to be when you go to the potty? Oh, do I have to threaten you with punishments in order to get you to remember? -4 divided by -2? You don't have to do it that way. You can do times -2 and then divide by -4. And then this is where we would come together again at this next step where I did this last period too. 150. Don't tell me. 1. So it's gonna be -2. 180 and 6. I think it's that. Jenny, do you agree with me? What do you mean 187? No, you're crazy. I'm right? Yosh. Now you get -2187. But then you gotta still get rid of the -1 in front, or Hannah will be very upset. And this one, I'm not guessing anymore because I did this last year, but at the time I guessed right. For the record, I guessed right. I believe it was 7, right? Thanks, Yash. Okay, back to our good old friend summation notation. See, the directions from the top still apply. They want us to find n. And I know this is kind of weird looking, but they have to give us the sum. What is the sum? Like, we're not finding sum. What is the sum? Yeah, negative 104. So negative 104. And let's do this actually. Let's make sure. So the sum of however many terms is negative 104, right? What's the common ratio here? Somebody not named Thomas, tell me this. Good, negative 5. Which stinks. Yeah, we don't. The ones we're finding number of terms with a negative ratio. But oh well. How about first amount? Let me ask Landon. He's focused right now. How do we find first amount in summation notation? No. I should have covered it earlier. Oh wait, I did. No. No. That's for number of terms, but that's what we're looking for. Like they're not giving us the upper, so we can't do that. Yeah. Plug in the lower limit in order to find the first amount, which is what I'm still missing. In order to find n, I need these other three. Plug in the lower limit. 1 minus 1 is 0. Anything to the 0 power is 1. Because of that 1, I don't need the parentheses or the 1 on the outside. I can just do 1 minus negative 5 to the n that I'm looking for over 1 minus negative 5. This becomes a plus. Negative 104 is 1 minus negative 5 to the n over 6. What would I do next? What? Camila, what do you want to do next? We're looking for n. Got to get rid of all this other junk that's around the n here. So, you want to ask Edvin? Edvin's thinking about it. Edvin, what do you think? Oh dear, who said that? Oof, no, definitely not. The 6 is good, but definitely not going to subtract it. Multiply by 6, that's good. That's going to get rid of the 6. Please do not combine the double negative. This is negative 624. 1 minus negative 5 to the n. Then just like on the other two problems we've done before, minus 1 minus 1. Negative 625 is equal to negative 5 to the n. How do we get rid of the negative? Multiply by negative 1. That's just going to change the sign. It's going to knock out the negative in front. It's the only way we can get rid of it. Uh-oh, Julian. What do we do here? You don't multiply anything. Yeah, you're basically just taking the log of the absolute value. Like, I know I have a negative 5 there, but I can't take log base negative 5. My calculator is going to give me an error. So I'll just take log base 5. And it'll still work. Yeah. Also, keep in mind context with these. Some people that blindly just use the calculator, let's say they made a mistake up here. Like, let's say perhaps maybe they forgot to subtract this 1. Well, what's going to happen is they're going to get a decimal there. Why can't I get a decimal? I'm looking for number of terms. I can't have, like, 4.27 terms. That doesn't make any sense. If I'm getting that, one of two things happened. Either the problem was written incorrectly or you made a mistake. You can't have, like, part of a term. We're looking for number of. The sums can be partial. The sums can have decimals, but not the number of terms. Yay, word problems, what we've been waiting for. Did I have any more left? Did I have another problem down there? No? Okay, good. So, word problems. The GHSA soccer tournament starts with 32 teams. How many matches must state administrators plan for in order to crown a state champion? Yeah, so there might be more than one way to do this. This is the way I approached it last time. I looked at the question and it says, hey, so we're looking at matches, right? They want to know matches. And they want to know a sum. So because they want to know, well, I wish they would have used the word total, but we're looking for total matches, so it's a sum. In order to find a sum, what do we need to know? And I'll show you why it's geometric now, but assuming it's geometric, what do we need? We need first amount, we need common ratio, and we need number of terms. For first amount, think about it. See, they told us there's 32 teams, but if we start with 32 teams in the first round, how many matches are there going to be? 16, because you need 2 teams to play against each other. And that's actually an important thing because watch, think about it. So if there's 16 matches, right? Let's go back to thinking of teams. After they play each other, how many teams are going to win if there's 16 matches? 16. So we'll go from 32 teams to 16 teams, then to 8. So what's happening every round? Half. That's what makes it geometric. We have a common ratio. Every new round, there's half the teams. Now, this might be the most interesting thing I think we've done today. And this makes me feel good about myself because I gave you an extra formula that I don't think the other kids have, and I don't mind if you use it. So we're looking for n, right? Well, hey, we just spent an entire page here looking for n. But the thing is, like, we don't have the sum. Like the last time we had the sum to work with, and here we don't. But I gave you a formula yesterday that said, well, look, another way to find n would be to say, all right, take the log, where the base of the log is the common ratio, which that we know. Okay, we know the common ratio, 1/2. And if it makes it more calculator friendly for you, just put 0.5. You can put 1/2 also. Of, and this is in your notes, the last amount. So on the last round, how many matches are there? 1. It's a championship game, so the last amount would be 1. And the first amount is, well, how many matches do we have in the first round? Yeah, and even I got messed up last period. I put 32 because I was thinking of the problem, but I forgot we're looking for matches. So at the first amount is 16. There's 16 matches. At the end, there'll be 1 match. This is going to tell me how many rounds. So try to put that in the calculator. What's log of 1/16 divided by log 0.5? Oh, and I'm sorry. The formula, I didn't write the formula also has a +1. It's in the formula, +1. What's log 1/16 divided by log 0.5? It is 4 plus that extra 1. This tells me that there's going to be 5 rounds of matches. Now I can find the total sum of the matches. So the sum of the matches in these 5 rounds is going to be 16. 1 minus 1/2. If it makes it easier to put in your calculator, put 0.5 to the power of 5 over 1 minus 0.5. If you want to put that whole thing in the calculator, that's fine, if you know how to do so. Actually, yeah, let's just do that out here just to save time. If you want, you could even do just maybe to make it a little bit easier. This here gives me 0.5. What's 16 divided by 0.5? No. 32 divided by 0.5 is 32. So if it makes it easier to put in your calculator, you can also put this 32, 1 minus 0.5 to the 5th. What do you get? Put that in the calculator. Somebody, so we can get through this. Ready, set, calculate. 31, thank you. So, again, I'm cool with you just going from here to here, that's fine. If you just jump there, that's fine. But if you want a couple extra steps so that you have to put less things in the calculator, that's, I think, a little better. Julian, you're probably thinking about why 32 divided by why 16 divided by 0.5 is 32. Is that what you're thinking about? You know that it is? Okay. So what's confusing you? No? Yeah, you had confusion face. Okay. This one's for Alexis because she loves word problems. Take another one here. This is an important one. Hint, 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 hint. A 6-year lease states that the annual rent for an office space is $84,000 for the first year, and it will increase by 8% each additional year. What will the total expense be for the 6-year lease? Back in Algebra 1, when you were just doing sequences, you learned the difference between an arithmetic and a geometric sequence. Okay? And you learn that when you're increasing by a percent, it's geometric. If you were increasing, like you were counting dollars here, if you were increasing by a dollar amount, if they would have said, hey, every year it goes up $8,000, so, plus 8,000, 8,000, 8,000, well, that's arithmetic, that's not geometric. But if you're going up by a percentage, it's geometric. And the common ratio, hint, 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 everybody, look at this, important, important, don't say I didn't tell you. The common ratio is not, oh, but that's 0.08, no. It's 1.08. To get it to go up, to get it to increase, you need the 1 in front. Well, okay, remember when we introduced exponentials and we talked about growth and decay? In order for something to go up, it has to be greater than 1. In order for it to go down, it has to be less than 1. So no, it's not that it would just be 0.8, but if it were 0.8, what would happen is it would go down. So when you multiply something by 0.8, it's going down. To get it to account, basically, in order to account for whatever there was previously, that's where the 1 comes from. When you go to a store and you pay sales tax, okay, sales tax might depend on what county you're in or something, but let's say you go somewhere and there's 6% sales tax, and whatever you buy costs $19.99. What the cash register is going to do is going to get the $19.99, not multiply it by 0.6. It's going to multiply it by 1.06 because the 1 accounts for the $19.99, and then on top of that plus the sales tax. So that 1.08 is accounting for whatever you already were paying plus an additional 8%. So don't say I didn't tell you. What's the first amount? 84,000. And we need the number of terms. How long is the lease? 6 years. Because of the decimals, I would say this is much more calculator intensive. So this would be an ideal candidate to just, you still got to substitute, but to then just pop it into the calculator. Here, this one, I'll let you see if you can put the whole thing in the calculator. You can maybe simplify it a little bit. Like last period, I simplified it a little bit. With that on the bottom, I cleaned it up. But let's see how good our calculator skills are. You already have it? No, you don't. I still like to go. So I'll go in order. 1 minus 1.08 power 6 divided by 1 minus 1.08 times 84,000. All right, so are we allowed to have a decimal here? Yeah, sure. We're finding a sum and it's money. What should the decimal be rounded to? Not tenths. Hundreds. Money is hundreds. So I'm getting, I'm scared I'm doing this wrong now because I felt like it'd be higher. Maybe not. I'm getting 616,218.04 and 4 cents. $616,000, 218. If you got the same thing, then you have good calculator skills. If not, you might have to do a couple extra steps just to make the numbers make there be less operations. Did anybody get something different and doesn't know? Even though Jenny has a fancy calculator where I could have put the whole thing inside, I just went in order. I did this first, I hit equals. Then I divided it by this, and then I multiplied that. I also could have, after I got the first number, I could have multiplied by 84,000 and then divided by it, which that would have been negative 0.8. No questions? All right. You guys are a little bit question. Yes, Julian. Can we just take the 8% of the just amount and then keep on adding? No, because every year it's going to change. You're going to be taking 8% of a bigger amount of a bigger amount of a bigger amount. All right. So, you guys are behind my first period. I didn't find this page to be all that great, so I'm going to skip it. It's not that big of a deal. And let's go to this one. And let's see if we can finish this today, and then we'll all be caught up. No, homework's online. This is just... Yes, the homework does have geometric series. That's what we've been doing all day today. Gosh. All right, so some of these 5 numbers. The key here is, oh, well, look, I can just put that in my calculator. 3 plus 6 plus... Yeah, but you're not going to be able to do that on the quiz and test. So let's use the formula. What's the first amount here? What's the common ratio? 2. Good. I'm going up by times 2. And what's the number of terms? That I can count here. How many terms are there? 5. So sum of these 5 numbers is equal to first amount, which is 3, 1 minus 2 to the 5th over 1 minus 2. I'll clean this one up a little bit. This is just 1 minus 32 over negative 1. So this is 3 times negative 31 over, I know that looks like a 7, but it's a negative 1. Sorry. And that's going to give me what, 93? If you add up all those numbers on top, you should get 93. Find the sum of the first 6 terms. What's my initial amount here? Yeah, a sub 1 is 4. What's my common ratio? How many numbers do I have? 6. So sum of these 6 numbers is equal to the first amount, which is 4, 1 minus 3 to the 6 over 1 minus 3. If you want to put the whole thing in the calculator at this point, that's fine. Jenny, what's 3 to the 6? 729? Okay, I'll take your word for it. Yash, you're worrying me though. And that's negative 2 on the bottom. So sum of negative 6 is 4 times, and actually better yet, just to really mess with you, these here I can cancel out and give me negative 2. So it's just going to be negative 2 times negative 728. What's that? 1456? And finally, I wish we had some more of these. Even though this is the last one and you tend to tune me out at the end, you might want to listen, because what's a little bit different about this one, that the common ratio is a fraction. You know, we haven't done a ton of these. I think we did one. But you just treat it the same. What's the first amount? 2. What's the common ratio here? 1/2. Good. Since you don't have to round, if you want to put 0.5, you can get away with it. And how many terms are there? 4. So the sum of these 4 numbers is equal to the 2, and then 1 minus 1/2 to the 4th over 1 minus 1/2. Sum of these 4 is equal to 2, 1 minus 1/2. And look, at this one here, what I'm going to do, I'm going to leave it as a fraction, just to I'm allowed to distribute that exponent. That becomes 1 over 16. On the bottom, I get 1/2. What's 2 divided by 1/2? What is 2 divided by 1/2? 4. Good. What's 1 minus 1 over 16? Remember, this 1 becomes 16 over 16. So wouldn't that become then 15 over 16? This becomes a 4. This becomes a 1. So we end up with sum of 4 is equal to 15 over 4. All right, we'll leave it at that. We'll continue Monday. Yeah. Huh? Yeah, and you would get away with it. That decimal's not too bad. That would be 3.75. What I'll warn you about decimals is that when the decimal gets too big, what do you guys like to do? Round. And you're only allowed to round if you're told to do so. Because then your sum would not be exact. But yeah, if you change the 1/2 to 0.5, you would have gotten away with it.